tilting rods. And I don't mean poker. Let's take a look at this question. It says, obviously, typical mechanics fashion, bunch of yap. AB is a non-uniform rod of length 16p and mass mkg. A particle of mass 3/44 mkg is attached at B and is then set to rest on two supports at C and D. Given that the rod is at the point of tilting, find the two possible values of locations of the center of mass from A. Okay, what's the key part of this question? Obviously it's saying it's tilting, but they don't say from which pivot. Okay, I've got myself a trusty ruler here to help us think about this. So you obviously have this mass, whoa. Ugh. We have this mass here fixed, right? We're going to have to draw some new diagrams, but just for concept for now, what is it? 3/44. So we have 3/44 mg. Now, that force may want to do this to the rod. It may want to rotate it this way. Now, if it rotates it that way, then there'll be no contact force with C. But obviously, we're talking about it being in equilibrium, so remaining horizontal. But the contact force with C would still have to be 0 at the point of tilting. Okay, it's at the point of tilting, meaning it's still horizontal, but it's just about to start doing this. It's just about to start leaving that pivot at C. But then there's the other case where, this center of mass, which we don't know where it is, might be in such a place that the 3/44 is not strong enough from the rod wanting to do this. So either it's going to do this or do this. And in either case, the contact force with one of the pivots is going to be 0. Okay, so let's draw both situations. Situation 1. So we have our two pivots. It's a rubbish triangle there. So we have, 3/44 mg. Now let's consider the first one I said where it wants to do this. It makes sense. Yeah, this force might want to rotate it this way. Now, if we do want to rotate it this way, there'll be no contact force at C. There's just going to be this contact force with D. We'll call it the reaction at D. Now, the only other force we need to consider is the center of mass, this mg. Where are we going to put it? Now, a lot of students would put it here. But, guys, if you put it over here, then the rod has to rotate no matter what. Yeah, it's not even at the point of tilting. It is going to be rotating. So, mg would have to be on this side. Yeah, mg is going to have to be on this side. But it's going to have to be pretty close to this pivot here at D, so that this is enough to rotate it. Okay? So, that way, just to remind you guys, that mg can't be over here because then it will rotate clockwise. All right. So we have A and B, and here we have C. Let's just say the distance between A and this center of mass is D1. Okay, because they said find the locations of the center of mass from A. So we're going to call that D1. Now let's take a look at the second situation. The second situation is basically exactly the same, but the contact force with D is now 0. We're going to consider the rod wanting to do this. Yeah? So you have D, but there's no contact force there. We're going to consider C. So we'll call that RC. Now, where would you guys put the center of mass so that this object wants to do this? Well, there's going to have to be a considerable force over here to pull it this way. Okay? So, for that, we're going to put mg on this side. A, B. And let's call that D2. Cool. I'll fill out the other lengths in a second. So let's consider situation 1. Where should we take moments from if we want to find D1? Well, D1's relative to A, so I recommend you take moments about A. Okay? But the first thing we can do is we can say RD equals the sum of these two. Okay? So looking at the up equals down, we're going to say RD is 1 mg plus 3/44, which is what? 47 over, where's my calculator? 47 over 44, 1 plus 3 over 44. Yeah, 47 over 44 mg. Now let's take moments about A. Now any downward force is going to be pointing down, obviously. That's going to be clockwise. So clockwise, clockwise. RD is pointing up, that is an anti-clockwise. So what is the difference of the distance between RD and A? So remember, it's force times distance. Now they did say the full thing was 16p, yeah, and this is 4p, yeah. 16 minus 4 is 12p. Equals this distance times 1 mg, which we just called it d1, and the full length times 3 over 44 mg. Now the full length is 16p. Now we have RD, which is 47 over 44 mg times 12p is d1 mg plus 3 over 44 times 16. Wait, what? Yeah, 3 over 44 times 16 is 12 over 11 mgp. Now you can see that all the mg's cancel, which is good stuff. That should always happen. We have to do 44 over... Wait, d1 could be rearranged here. d1 is this times 12 minus the answer I've got here. So I'm going to do 47 over 44 times 12 minus 12 over 11. 129 over 11. And it's p. Okay? Which works out to like 11.7. So this distance here is about 11.7. Makes sense. Yeah, still shorter than that 12, so the diagram makes sense here. Okay? So let's look at number 2. Now number 2, the up equals down is still the same situation. So RC is still our 47 over 44 mg. Now let's take moments about A. And this is the thing, it's just the exact same stuff. So we're doing D2, so everything downward force is the same, is clockwise, sorry, is D2 mg plus that 16 times this. The 16 times this was 12 over 11 mg. P is that distance, which we can see as 5p, RC. Which we know RC is 47 over 44 mg. Mg's all cancel. So we're doing 5 times this minus 12 over 11. 5, I already have the calculation here. 5 times 47 over 44 minus 12 over 11, I get 17 over 4. So D2 is 17 over 4 p, which, if you decimalize, 4.25. So this is 5p, this is 4.25, so maybe like much closer here, but in terms of the diagram, it doesn't make a difference. But there you go, guys. Still a reasonably tough question. Students would really struggle with a question like this. So guys, if you learned something today, I'd really appreciate if you hit the like button, subscribe for more maths content, and if you're interested in my A-level maths courses, more details are in the description, and feel free to join the Learn Gang Reddit page if you want to submit your own questions and get feedback from the community. Nice.